Hi everyone, welcome back to a new video, and today we'll talk about how to choose between Sn1s, Sn2s, E1 and E2 reactions. So first of all, it's important to locate the alkyl halide and determine whether it's a primary carbon or the carbon that is attached to the halogen. It's good to label them as a 1 or a primary carbon, a secondary carbon, or a tertiary carbon. That is because substitution reactions need to attack the carbon, right? And for it to occur in one step, thus the leaving group leaving at the same time as the attack, the carbon itself or the electrophile needs to be unhindered. So it doesn't need to have bulky groups beside it, or else we need the leaving group to leave first, creating a carbocation, and then the leaving group, the nucleophile can attack. So this is the difference between an Sn1 and Sn2. So usually for Sn1s and Sn2s, we prioritize primary carbon with Sn2s. So Sn2s, it's instantly, so it's a one-step reaction. Because it is unhindered, the carbon is primary, so it's only attached to one other carbon group. So it's unhindered, so the leaving group can leave at the same time as the nucleophile. The nucleophile attacks. Sorry. So the primary is usually with Sn2s, and tertiary carbons are usually with Sn1s. Sorry, because it's hindered. So it won't be able to attack because the carbon group will be too hindered. So we need the leaving group to leave first. So, and then for E1s and E2s, it's to determine whether it's going to be, so usually Sn2s and E2s are going to be bonded together, I'd say, even though most of the time it's whether going to be Sn2 or E2. And Sn1s and E1s always occur at the same time. So, but whether it's going to be a substitution or an elimination, it really depends on the strength of the base. So a nucleophile can be a strong base, like OH minus, or that stuff, but it can also be a strong nucleophile and a weak base, like in the case of where a nucleophile has resonance, so it allows it to be a base or wanting to be a base, but it can still act as a strong nucleophile because it is an anion. So when it's a base, it's usually going to want to deprotonate the hydrogen surrounding that carbon, creating that elimination mechanism. So like we said, the first step would be to classify the alkyl halide as primary, secondary, right? Tertiary. The second thing would be to classify the base or nucleophile as strong, weak, or bulky. So good nucleophile but weak bases will favor substitution. Like I said, so good nucleophile but weak base, they'll usually favor substitution, like I minus, Br minus, HS minus, Cn minus, etc. Bulky, non-nucleophilic bases will favor elimination because they're bulky themselves, so they won't be able to actually attack the carbonyl group and do a substitution. So they will act or do an elimination reaction instead and deprotonate the neighboring hydrogen that's attached to the neighboring carbon. So here are some examples of a good nucleophile but weak base, and here bulky non-nucleophilic bases. And at the bottom here I did a little summary. So in here you can see the alkyl halide type. So primary, secondary, and tertiary here. If you have a primary alkyl halide, you have a strong nucleophile and a strong base. In this case, the strong nucleophile is going to win, or it's going to win because it is the alkyl halide is unhindered, so you'll obtain the mechanism only in Sn2. Here, if you have a strong, bulky non-nucleophilic base, then E2 is going to occur. For a secondary carbon, a strong base, if you have a strong base and a strong nucleophile, you'll have a mixture of Sn2s and E2s, but in this case it's mostly going to be E2. And here, if you have a strong but bulky non-nucleophilic base, it's also going to be an E2. It's in this case, it's very important to understand when you have a strong bulky base, it's always going to be an elimination reaction, because it won't ever be able to do a substitution. And then here in this case, if you have a weak base and a weak nucleophile, obviously you'll go with a mixture of Sn1 and E1. So Sn1s and E1s always come together. So you need to give both products. And for a tertiary alkyl halide, a weak base and weak nucleophile is also going to be Sn1 and E1. And a strong base is going to give you an E2 mechanism. So this is a little summary that's going to help you determine between Sn1, Sn2s, E1s, and E2s. Don't forget to do, when you have problems, do the steps, those 2 steps, and then this will help you in determining. So here are some examples, problems, some simple problems. So let's look at the first one. So here we locate our alkyl halide here. We can see that it's bonded to a carbon that's bonded to 1, 2, and 3. So we know it's tertiary. And water, we talked about, is a weak nucleophile. It's also a weak base. So weak nucleophile, weak base with a tertiary alkyl halide, we obtain an E1 and Sn1 reaction. So an E1 reaction in this case, we'll first have, the first step is going to be that leaving group leaves, and we obtain this carbocation here. Now the E1 can eliminate or deprotonate every surrounding carbon. But you can see, as you can see here, this is a quaternary carbon, so it doesn't have any hydrogen, so it cannot be deprotonate. And then this hydrogen here, it's the same as this one, because they are here. You can see it's the same thing. So the only deprotonation is going to be here. This is going to roll on here, creating this E1 product. For the Sn1, same thing. We also have a carbocation, but now this time water is going to attack here, giving us this intermediate with the oxygen with a positively charged oxygen here. And then we use water again to deprotonate it, giving us this Sn1 product. So this is the example, first example. Let's do the second example here. So here we can locate the alkyl halide. So and then we can see it's bound to 1 and 2 carbon. So it's a secondary alkyl halide, and we know that CH3O- is a strong nucleophile, and it's also a strong base. So a secondary halide with this type of nucleophile is a mixture of an Sn2 and E2. So in this case, E2. You know, in E2 and Sn2, it's a one-step mechanism. So we have the attack, or the leaving group, then the nucleophile attacks and deprotonates this hydrogen, and this one rolls up. And then it's the same thing as the previous example. It could also deprotonate this one here, but it's the same. They are the same carbon, so they would give us the same product. So here's our E2 product that we obtain with by doing the E2, and then the Sn2 is very simple as well. So we have Br leaving, or the leaving group leaving, and then nucleophile attacks this carbon here. And then because there is no stereochemistry here in this case, right? Because this carbon's attached to same group, so we don't have to focus on stereochemistry. And then we obtain this product as our Sn2 product. All right, and here we have, we can locate this carbon attached to our halogen. So we have our alkyl halide here. This is a tertiary carbon. And we have here an alcohol, which is a weak base and also a weak nucleophile. So tertiary, weak base, weak nucleophile. It's a mixture of Sn1 and E1. So first thing first, we have our halogen leaving. We then obtain this carbocation for the E1 for elimination. So now we can see that this carbon is neighbor. As this carbon is neighbor, this carbon is neighbor, this carbon is neighbor. These two are the same. So the nucleophile is only going to attack one of them. But this portion here, which is an ethyl group, is different from the previous ones. So you know that the nucleophile can deprotonate two carbon. So we will have two products. In this case, if it deprotonates over here, we have this product here, which is disubstituted. If we deprotonate here, we have this product, which is trisubstituted. So, as we mentioned in the previous video, the more substituted the alkene, the more stable it is. So the trisubstituted product is the major product, and the disubstituted product is the minor product. Alright, now for the Sn1 portion of the reaction, we have a carbocation that's being attacked by the nucleophile, and then same thing, we have a positive charge that we will then deprotonate it, allowing the bond to roll over and then give us our Sn1 product. So those are the three examples. I hope this helped. Make sure to do the steps. So locate your alkyl halide, classify it as a primary, secondary, or tertiary. Look at your nucleophile, classify it as a strong nucleophile, weak nucleophile, classify its strength or its basic strength, and also try to locate if it's bulky or not. And then this is going to help you a lot figuring out which of these four reactions you need to use. So I hope this helped, and thank you for watching.